Most quality problems are discovered too late, during production, audits, or worse, at the customer. Teams then react with firefighting, corrective actions, and costly delays. But what if you could identify failures before they happen? In this masterclass, you will learn how to use FMEA step by step to predict risks, prevent defects, and build stable processes from the start. FMEA stands for Failure Mode and Effects Analysis. It is a structured method used to identify potential failures before they happen. Instead of reacting to problems, FMEA helps teams evaluate risk early and introduce preventive controls. Every risk is assessed through 3 questions: severity, occurrence, and detection. The goal is simple: prevent problems and build stable processes. FMEA can be applied at different stages of a product or process lifecycle. The 3 most common types are design, process, and system FMEA. Design FMEA focuses on product design, identifying risks before manufacturing begins. Process FMEA evaluates risks within manufacturing and operational steps. System FMEA analyzes interactions between multiple systems and functions. While each type has a different focus, the objective remains the same: prevent failures before they reach the customer. FMEA is not a one-time activity. It is triggered by change. Typical triggers for starting or updating an FMEA include a new product or process, introduction, design or engineering changes, new equipment or manufacturing technology, supplier changes or new materials, recurring quality issues, or customer or audit requirements. In simple terms, whenever something changes, risk changes as well. FMEA ensures those risks are evaluated before problems reach production or the customer. FMEA should never be created by one person alone. It is a cross-functional activity combining engineering, production, quality, and sometimes suppliers. Engineering understands the design intent. Production understands how the process actually runs. Quality brings risk thinking and control logic. One person acts as facilitator, guiding the discussion and maintaining structure. The process owner remains responsible for implementing actions and keeping the FMEA updated. Collaboration turns FMEA from paperwork into real prevention. An FMEA is built as a structured table that analyzes risk step by step. For each process step, the team identifies what could go wrong, the failure mode. Then, the impact of that failure is described, the effect. Next, possible causes are defined. Existing controls are documented, and each risk is evaluated using 3 criteria: severity, occurrence, and detection. Severity measures how serious the impact would be if the failure happens. It is rated from 1 for very low impact to 10 for extremely high impact. Occurrence measures how often the failure is likely to happen. 1 means it almost never occurs. 5 means it happens from time to time, and 10 means it happens very frequently. Detection measures how likely the current controls are to detect the failure before it reaches the customer. 1 means the issue is obvious and easy to detect, while 10 means detection is very unlikely. These 3 numbers are multiplied to calculate the risk priority number, or RPN. RPN equals severity times occurrence times detection. The higher the RPN, the higher the risk, and actions should always prioritize the highest RPN values first. Last but not least, remember the FMEA header, where key information is documented, such as the process or product name. The FMEA refers to the responsible owner, the initialization date, and the latest update. Remember, FMEA is a living document that should be continuously updated as the process evolves. The purpose of the FMEA table is simple: make risk visible and manageable. Let's look at how FMEA is used in practice, using the scratches case. The team reviews the packaging process. One identified failure mode is components scratching each other during packaging or transport. The risk is evaluated. Severity: 8, because damaged parts lead to customer complaints and rejected shipments. Occurrence: 7, since components are packed without separators. Detection: 6, scratches are usually discovered only by the customer. The RPN is 336, which indicates a high risk. Other risks in the same FMEA have much lower values. For example, incorrect box labeling might have an RPN of 45 and minor packaging deformation an RPN of 80. By comparing these numbers, the team clearly sees that scratches are the highest priority. The root cause is identified: no protective separators between components. The improvement action is to introduce protective separators in the packaging. After implementing the change, the FMEA is updated. Severity now is 8, occurrence now is 2, detection now is 3. The new RPN drops to 48, confirming that the risk has been significantly reduced. This shows how FMEA helps teams prioritize risks and verify that improvements actually reduce them. Even a well-structured FMEA can fail if it is poorly applied. Let's use our packaging example to understand the most common mistakes. Mistake 1. Treating FMEA as a one-time document. A frequent mistake is creating the FMEA once and never updating it. For example, if packaging material changes but the FMEA is not revised, the documented risk no longer reflects reality. FMEA must evolve whenever the process changes. Mistake 2. Copy-paste from previous projects. Another mistake is copying an old FMEA without analyzing the current situation. The packaging process for one product may not apply to another. Assumptions replace analysis, and real risks remain hidden. Mistake 3. Scoring. Without discussion, teams sometimes assign severity, occurrence, and detection values without real debate or data. For example, rating occurrence as low without reviewing defect history creates false confidence. Risk scoring must be evidence-based. Mistake 4. No link to real controls. If the FMEA identifies scratches as high risk, but no protective packaging is implemented, the document becomes theoretical. Actions must be implemented, verified, and reflected in the control plan. Mistake 5. No follow-up. After actions are defined, some teams never re-evaluate the risk. Without updating ratings after improvements, the loop remains open. FMEA is complete only when risk is reduced and confirmed. FMEA is not about filling a table. It is about disciplined thinking, structured discussion, and continuous improvement. FMEA does not exist in isolation. It is part of a larger quality and risk management system. The outputs of FMEA directly influence other operational tools. First, FMEA supports the control plan. High-risk items identified in FMEA must be reflected in process controls and inspection points. Second, FMEA connects to SCAR. If recurring failures occur, it often means the original FMEA underestimated the risk or missed a cause. Third, FMEA supports audits. Auditors frequently verify whether risks identified in FMEA are properly controlled in reality. And finally, FMEA supports continuous improvement. It transforms past problems into structured prevention for the future. When properly maintained, FMEA becomes the backbone of proactive quality management. FMEA is not just a document. It is a structured way to prevent failure before it happens. Use it early. Keep it updated. That is how organizations move from reactive correction to preventive excellence. Explore our other masterclasses and subscribe for more supply chain and quality insights.